Welcome back. Let's study sound waves. I show a speaker oscillating at a frequency F. The membrane is vibrating right and left, back and forth, pushing on the air in front of it, and like dominoes tip over, you've got this progression of air advancing to the right at a speed, which is called the speed of sound, 340 meters per second, moving to the right. You have regions of air in front of the speaker membrane that are at normal air pressure, higher than normal, normal, lower than normal, back to normal, then high. The distance between consecutive highs is called a wavelength. We can graph the pressure variation as a function of distance, shown here. The vertical axis is delta P, which is the difference between the actual pressure, wherever, and normal air pressure, P naught. At this location, the pressure of the air is normal, and so we have delta P is P naught minus P naught, or a 0. Then we have these other values of delta P. Higher than normal air pressure gives a positive value for delta P. Back to normal, then lower than normal air pressure here, delta P would be a negative number. Back to normal, it's a 0 again, and up to a high there where delta P is positive. These places where there is an extreme behavior, higher than normal air pressure or lower than normal air pressure, are called antinodes. Places where there is no variation from normal are called nodes. There's a node, there's another one, yet another one. Now, the sound wave propagates according to a wave equation that you've seen before. The product of the frequency of the wave and the wavelength of the wave is the speed of the wave, in this case 340. Now, let me, before moving on, point out to you that the distance between consecutive letters, NH, NH, or HN, or NH, all the same values, and that it takes 4 of these distances to make a full wavelength. 1, 2, 3, 4, adding up to a lambda. And so the distance between an H and an N, or an L and an N, here to there, is 1/4 of the whole. And so the distance between consecutive labels in my sound wave is 1/4 lambda. Humans can detect sound frequencies between 120 hertz up to 12,000 hertz. It's an interesting factoid that doubling the frequency of speech increases its clarity. Now, speech doesn't just consist of one single frequency or one tone, it's a mixture. But in general, if you increase the frequency, the pitch of a spoken word, it's clearer or heard more clearly by listeners.